Hi. So let's continue to talk about the QoS on Linux open source firewall or router. So I always come back to this article about configure QoS on GNU Linux with the TC command. So I have a specific challenge about ingress traffic shaping, which the TC has limitation. So for example here, limit download ingress rate. QDisks ingress traffic only provide parsing without shaping. So to shape ingress traffic, the ifb intermediate function block device must be used. So for example here it has this beautiful picture here. For the egress traffic shaping, we already done that. But for the ingress traffic shaping, say for example, download traffic shaping, if you have if you want to limit some traffic bandwidth on your local network or on your local servers, how can you do the ingress traffic shaping based on your local server source IP address? So you needed again, you needed to have this device. This device must be used. So here's a step-by-step instructions and to set up ingress traffic shaping. For example, here this is another diagram, a beautiful diagram, colorful. And for example, if you have a Linux server in your local network, you want to limit the bandwidth, the download bandwidth for those servers. How can you do that? Because the challenge here is that if you want to do the ingress traffic shaping on this internet-facing interface for ingress, you must use the ifb modules or the devices to mirror the traffic, to mirror the ingress traffic to the ETH0 to the ifb0 as egress traffic. Then you can do the traffic shaping on the ifb0 egress. So that's eventually what this article does. So here's a full script to do the ingress shaping on the internet side interface. So first you need to load the kernel module ifb and also schedule fqqdel. Also this module, act mirror module. Then you would set up the ifb0 up. Okay. Like so for upload, for egress traffic, it follows the previous instruction I demonstrated in my video. yeah, so you just add the QDisk on the ETH0 interface. That is to facing the internet side. So in my open source firewall, that would be the red 0 interface. Yeah, so set up the QDisk, set up the class. Let's make it bigger, and then set up the subclass for your servers, for your normal users, or for your Wi-Fi devices in your local network. So that's for egress traffic shaping, right? That's simple. And also you attach filter with the class, and you use the handle one FW. So that is the IP, that is to use the IP table rules to set up the firewall mark, and so the filter knows the traffic and direct the firewall marked packet to the class ID. So this is for egress, and yeah. But now the challenge is for the download ingress traffic. And how do you do that? So first you set up the QDisk on the IFB0 interface. So this is also for egress, right? But it's on the IFB0. It's similar to set up on the ETH0 for egress traffic shaping. And you set up the class with the bandwidth. And also you set up the filter with the firewall mark, handle 1 FW, handle 2 FW. So that's the firewall mark number for the users, for the servers, for the Wi-Fi users. So here is the interesting part. You create ingress on the external interface. So here you set up the QDisk on the ETH0 interface with the ingress. So here notice, here is ingress. Okay. So like in the egress traffic shaping, here you set up the same QDisk, but there is no by default. This is for egress without the ingress word. But here when you set up a QDisk for the ingress, you need to specifically use the ingress word. Okay, so that's set up the ingress. Now you need to mirror the ingress traffic on external interface to the IFB interface. See here it says forward all ingress traffic to the IFB device, and then here is how you do it. TC filter add dev external interface, protocol IP. So forward all the redirect all the IP traffic from the external interface ETH0 to the IFB0 interface as a egress mirrored, right? Yeah. So once all the traffic is redirected to the IFB0 device, then you have all this QDisk class filter, and then you are able to do ingress traffic shaping. But there's still one thing we need to use IP tables. Remember, we have this TC filter firewall handle one, and so where you set this up. So that is the job of IP tables. Here you set up, for example, for the server for source IP address from the servers. You use the mark module and set up the mark with number 1, right? So that's the set mark 1 is correlated to this handle 1 FW. So when you have a packet originated from this server subnet, it will have the mark number 1, and then in the TC filter, when it sees the packet has firewall mark 1, it will forward it to the direct to the class ID 2:10, and this is the class ID 10 to limit the rate to 400 megabit per second. Okay, so you needed the IP job to IP tables to do the firewall mark, similar to the users subnet, similar to the Wi-Fi subnet. You set up the mark. Okay, yeah. So that's how traditionally it achieves the ingress traffic shaping. And so if you read more about this article, there is okay. So here actually another article. This is in the wiki page of archlinux.org. It also mentions the same method to do the ingress traffic shaping here. Say example of ingress traffic shaping with a SNAT. So here we needed to talk a little bit about the SNAT. So QDisk ingress traffic provide only policing with no shaping. Again, right? In order to shape ingress, the IFB intermediate functional block device has to be used. However, another problem arises if SNAT or masquerade is in use. So here is the situation, like you have an open source firewall router or open source firewall. If the traffic is from your internal servers, and when you do the ingress traffic shaping on the external network interface, your source IP address is translated to the router's IP address on the external interface. So that's what it says with a SLAT, because the source address translation or masquerade. So all the incoming traffic has the same destination IP address. It means like when your internal local network traffic going out, and then when the internet traffic comes back from the outside internet, on your router external interface, the ingress traffic has the same destination IP address, which is your IP address on the router external interface. It's not your local network source IP address. The QDisk intercepts the incoming traffic. The QDisk intercepts the incoming traffic on the external interface before reverse /translation, so it can only see the router's IP on the destination of an IP packet. Yeah, so that's what I just said. It's only see the router's IP as the destination of the packet. So here the following solution is implemented on OpenWRT, which is another popular home router or firewall. And so it used the first outgoing packet is marked with mark number and corresponding collections with com mark. On the incoming packet, ingress U32 filter redirect the traffic, the ingress traffic, to the IFB interface action mirror, and also retrieve the mark of the packet from collection track, so it knows the original source IP address. Provide information as to which IP behind the NAT initiated the traffic. Okay, so here's another bash example, which is exactly to the previous article I just mentioned. You know, use the mark and use the U32 to mirror the ingress traffic to the egress side of IFB0. And yeah, similar to this guy. Okay, so yeah, here I just want to explain how the ingress traffic shaping works traditionally. But in my next video, I will talk about how we remove this IP table use. We use the eBPF classification filter to work around these IP tables, because I don't like the IP tables. Like if you have many local network, if you have many requirements for ingress traffic shaping, then you need to set up those IP table rules, firewall mark. That becomes a little difficult to manage, right? So if we have a eBPF program to replace this part, and it improves programmability and flexibility. So I'll talk about that in my next video. Okay, thanks for watching. Hope you learned something.